Good morning, everybody. I hope y'all are having a lovely weekend. It is day 4 of the advent of code, and today we are working with camp cleanup. You see here, space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, some of the elves compare their section assignments with each other. They've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, which will be our puzzle input. For example, if we consider the following list of section assignments, we can see that Elf 1 in the pair has to clean out sections 2 through 4, and Elf 2 has to clean out sections 6 through 8. Now, some of these pairs have noticed that their assignments are fully within another's assignments. For example, if we look at this one right here, we have one elf cleaning out section 2 through 8, while the other elf is cleaning out section 3 through 7. Elf 2 is going to be cleaning things that Elf 1 is already working on. So our assignment for right now is to see how many pairs does one range fully contain the other. We can go look at our puzzle input right here, and you can see we have a lot of pairs to work with. Quite a bit of splitting I think we can do today. We can do probably read lines, then we can split at the comma. We are over here in VS Code where we have our input 4 put in and our day 4 file ready to work with. So we will go ahead and start working on defining our parser for the day. As always, we'll go ahead and open up input4.txt in read mode. We'll be returning a list comprehension. Go ahead and strip out that new line, split at the comma right there, and we'll create a second list comprehension within it. Now we'll have a third list comprehension inside of the second one, which will be converting each pair into numbers, integers that we can use, which printing this, you can see right here that we have everything converted so that we can do nice, easy comparisons. Now that that's done, we can go ahead and start defining our process, which of course will take in the pairs that we just created. And the first thing we do in it will be to define a helper function, which is a lambda. And our lambda will take in a single pair. Now this lambda is going to be responsible for checking the pairs. If the first half of it fits into the second, or the second half of it fits into the first, then we'll know that it is totally overlapping and we can add it to our total value. To do that, we need to check two conditions. One for the first, or one for the second. If either of these are true, then we can return true. We need to compare the first value of the first pair to the first value of the second pair, and the second value of the first pair to the second value of the second pair. Something a bit like this. Quite a bit of a long condition here, but as you can see, we're essentially just comparing the two sets, or the two halves of the pair to each other to see if one fits into the other. After this, it should be pretty simple. We can just sum another list comprehension where we call helper on each pair in pairs. Then we'll print out our process on our parser and see if we get an answer we can use. Whoops, little error right there in our list comprehension. Let's fix that. And now to try again. 462 is the value we are given. We'll head over to Inventive Code and see if that works. Alright, we're over in Inventive Code, so let's go ahead and enter our number here and submit. And we have a right answer. That is our first part for the day done, so now we can continue to part 2. Now it seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. So in this example, they want the number of overlapping pairs at all. Alright, I don't think this should be too hard to do. We'll go ahead and define a process 2. And really, I think we can use our above as kind of a template. Really, we can do about the same thing. We'll just be seeing if it overlaps at all instead of overlapping entirely. Now what we can do actually, I believe, is instead of having these two conditions that have to be right, we only need to see if one of the numbers fits anywhere inside of the other. So we'll have to be checking 4 numbers now. Instead of just 2, we'll check pair 0, 0, pair 0, 1, pair 1, 0, and pair 1, 1. I think we can do something like this for each number, where we have the number we're wanting to compare in the center of the other two lists' extremes. If pair 0, 0 is more than or equal to pair 1, 0 and less than or equal to pair 1, 1, then it is somewhere in that range, which means that there is some overlap. So if we do that for all 4 numbers, and if any of those have an overlap, then we'll be sure that that has an overlap within that pair. So now we just need to do it for the other 3 of these. Alright, we have 3 and 4 done, and now since we're checking all 4 numbers, in theory, that should be able to check for overlap among any of the pairs. So now we'll go ahead and print process 2 on our parser and see what we get from that. 835. That sounds reasonable out of 1,000 pairs. Alright, here we are. We're going to type in that answer we got, 835, and submitting. That is the right answer. We did get it. Woohoo! Well, I think that was an excellent day 4. Nothing too fancy today. We didn't get to work with sets like yesterday, but we got to use some tried and true methods, and I think it was just an absolute joy. If y'all enjoyed, please consider leaving a like or a comment. That would be absolutely amazing. I'll have the work that I did today on my GitHub, and I'll have that link down in the description for y'all if any of y'all want to go take a look at it. Otherwise, that'll be it for me today. I'll be back tomorrow. Until then, I'll see y'all, and y'all take care.